right, so what I want to talk about now is I want to talk about what happens. So another kind of question that might show up, or the kind of question that could show up, which is basically for a confidence interval, what happens if I'm given the margin, if I want to find the margin of error or a point estimate and I'm given a confidence interval, right? And so basically this is how do we understand how a confidence interval is set up? So let's say, for example, I've got this example which says a small group of hummingbirds has been understudied in a specific region for their weight. Based on past history, it appears that the weights of hummingbirds have a normal distribution with sigma equals to 0.33 grams. Okay, for this situation, you find a 99% confidence interval of 2.931 to 3.369. What is the margin of error and the sample mean for this scenario? So I always want to be thinking to myself, okay, well, some basic information. What am I looking for? This is going to be an interval for the mean, right? And so that's going to be really important because it will tell me what kind of point estimate I'm going to be looking for. So it's an interval for the mean. So my point estimate, called my PI, okay, is going to be X bar. All right. And then I'm going to have a margin of error. Now, essentially, if I think about this, in fact, I'm going to think about this, I've got my lower limit, okay, my lower limit to my confidence interval, which is 2.931. That's sitting right here. And then I have my upper limit to my confidence interval, which is 3.369. Okay? And what I know from my construction is that X bar is going to sit right in the middle of that. So X bar is going to sit right in the middle of that. So how I'm going to find X bar is, so X bar is going to equal my lower limit plus my upper limit divided by 2. And there's an online calculator that'll allow you to do this. Divided by 2, okay? And so that's going to equal, right? Because basically if I add these two together and divide by 2, I'm using something called a midpoint rule, right? And so it's like I'm splitting the difference. I'm taking the average of the two, and the middle line is going to be the average of those two, okay? So that's going to be 2.931 plus 3.369 divided by 2, which equals 3.15. Awesome. All right, super interested in that. That's going to be my X bar. So X bar equals 3.15. Okay. Now, the next thing that I want to do is to find my margin of error. And so what I want to remember is that my margin of error is this distance right there. It's that distance. Okay. So the margin of error is going to be the upper limit minus X bar, or if we were doing P hat, minus whatever the point estimate is. So it's the upper limit minus the point estimate. In this case, this equals 3.369 minus 3.15, which equals, let's take a look, 3.369 minus 3.15, 0.219. And so that's my margin of error. Which you also see as E. Okay? All right? So there's my margin of error. And so that distance right there is 0.219. Okay? So we found our crucial information just given the confidence interval, knowing how it is set up, right? That X bar is going to be in the middle, and then my margin of error is the distance from either side. So now let's take a look at another question. So remember, this is the sample evidence that I gathered created this confidence interval. Okay, and I'm going to write out my confidence interval again just so that I remember what it is. Okay, it's going to be 2.931 to 3.369. Okay, so as you're working, you're going to have that information. Okay, so suppose you wanted to determine if since the introduction of new chemical fertilizer, okay, that the size of the hummingbirds has decreased since 2008. In 2008, the average hummingbird weighed 3.7 grams. Do you have evidence that the weight of the birds has decreased? Well, now what we're going to do is we're going to see is 3.7 in the interval. And the answer is no, it is not. So this is from today. This information is from today. This is from 2008. Okay. So what we've got is that my evidence from today doesn't include 3.7. And remember, right, this is 99% confidence. So 99% of the intervals that I'm going to construct this way are actually going to contain the true mean, or excuse me, the true mean, hummingbird weight. So 3.7 is not in my interval. It's really unlikely that 3.7 is actually the true weight. Okay? All right, so 3.7 is not in the interval. So it is unlikely it is the true weight. So no, it wouldn't say 3.7. Now the question though is, did it decrease? Well, 3.7 is what it is in 2008, okay? Since 3.7 is greater than every value in the confidence interval, right? And 3.7 is that 2008 data, okay? So 2008, right, we had a higher number than what we've got today, right, just for the entirety of our interval. So since 3.7 is greater than every value in the confidence interval, this tells us that the size of hummingbirds has decreased. This is basically, we've rejected the null hypothesis. This was the null, right? This was like mu equals 3.7. That's my null. Since it's not in the confidence interval, I'm going to reject it. And in fact, since the confidence interval is completely below 3.7, what that tells me is that the value for mean hummingbird weight has actually decreased. Okay? Has decreased. Okay? So again, we're testing, like basically this is literally a hypothesis test. What we're doing is we're testing to see, is the value that we're claiming, 3.7, in the interval, right? And the answer is no, it's not in the interval. So it's not 3.7 today. Today's data says not 3.7. In fact, because all of these values are less than 3.7, everyone from 2.931 to 3.369 is less than 3.7, that tells me that in fact the weight has decreased. Okay? So that completes this video. Let's actually just review really quickly, so because it's not incredibly difficult, okay? It's just a basic concept here. If we're given the interval, so we've given the interval like this, okay? How do we find the margin of error and the point estimate? Well, what I do is I first find the point estimate by using this midpoint rule right here, okay? So that's the x bar equals the lower limit plus the upper limit divided by 2. Then, once I've found that, I'm going to plug that into this thing, upper limit minus x bar, to give me my margin of error. And there it is, okay? Straightforward, right? Try not to complicate it too much, because you're not going to need to find z alpha over 2. You're not going to be finding standard errors. All you're going to need to do is to find the margin of error and the point estimate given an interval, and that's just some simple addition, subtraction, and division. Okay, that concludes the video.